test. So first, what it is. The Kruskal Wallis test, also known as an H-test, is a non-hermetic test that determines whether the medians of two or more groups are different. Our null hypothesis would be that the distributions are the same. The alternative would be that they are not the same, or that they are different. How to determine whether this is the right test you should be using. So these are the key things you should look for when trying to figure out if you should use a Kruskal Wallis test. First thing is that it should be an interval or ratio scale. Second thing is that you should be looking for differences. Third thing is that there are two variables, one independent and one dependent. Fourth thing is that the samples have to be independent. And the fifth thing is that the distributions are not normal. This is the formula. It looks a bit complex, but I assure you it is not difficult. The H is just a notation for Kruskal Wallis. The 12 and the 3 will not change. They are just standard parts of the equation. The R is the sum of ranks. The big N is the amount of numbers you have. And the small n is the amount of people you have. Once you have figured out your test statistic, the next thing would be to figure out your critical value. Of course, to figure out your critical value, you have to know the degrees of freedom. For a Kruskal Wallis test, it's fairly simple. You just subtract the number of categories minus 1, and those will be your degrees of freedom. So this is the example we're going to be using to solve a Kruskal Wallis problem. The professor wants to know if the color of a room affects test scores. He has 15 students take a 30-question test. He puts 5 in a green room, 5 in a red room, and 5 in a blue room. So we are going to use the data to conclude if the room color has an effect in the testing distributions. Okay, so this is the data set we're going to be using. We have green room, red room, and blue room. For green, we have 15, 18, 27, 11, and 5. For red, we have 11, 14, 8, 9, and 7. And for blue, we have 30, 29, 13, 19, and 25. As you can see, if we were to plot this out, this would not be a standard bell curve, so this is not a normal distribution. So the first step would be to rank from the smallest to the largest. This is for the whole data set. So in this case, number 1 would be 5. Moving up, number 2 would be 8. Number 3 would be 9, and so forth. Our last data point, our last rank is going to be 15, which is at 30. If you have a number lower than 15 or higher than 15, you did something wrong because there is only 15 data points. For numbers that show up twice, like in this case, 11 did, so 11 and 11, one in the red, one in the green, you want to separate two ranks. So here we have 4.5, 4.5 again, which is going to count from 5. Then we move up to 6 and just continue to the next one. So the next step would be to add up the ranks. So for green, we're not going to add the 15, the 18, or the 27. We're actually going to add the 8, the 10, the 13, the 4.5, and the 1. Once we get our answer, which is going to be 36.5, we're going to square it and divide it by the number of data points in that category. In this case, it is 5. So we're going to do 36.5 squared over 5, which is going to give us the grand total of 266.45. We're going to continue and do this for each category. For red, the sum of ranks is going to be 25.5, We're going to square that, divide it by 5, because that's how many data points are in this category, and we end up with 130.05. For blue, we're going to do the exact same thing. Add up the 15, the 14, the 6, the 11, and the 12. End up with 58. We're going to square that, divide it by 5, and our grand total is 672.8. Now that we have calculated the sum of ranks, we can go ahead and put them into our equation. So again, H, notation for Kruskal Wallis, equals 12, which is just standard number there, over 15, because in the whole data set there are 15 points, times 15 plus 1, which is going to be again n plus 1, the sum of ranks, which is going to be the 266.45, plus the 130.05, plus the 672.8, and once we add those up, we're going to subtract 3 times n plus 1, which again is going to be 15 plus 1. Once we calculate the test statistic, which in this case is going to end up to be 5.465, we can move on to find the degrees of freedom. So again, degrees of freedom is just categories minus 1. In this case, in our data set, we only had 3 categories, which was the green room, red room, and blue room. So 3 minus 1 is 2. Now that we have our degrees of freedom, we are free to calculate our critical value. To find the critical value, we're going to be using a chi-square table. So at a 0.05 value, and with 2 degrees of freedom, our critical value is going to be 5.991. So now we have our test statistic, which is going to be our Kruskal Wallis statistic, 5.465, and our critical value is going to be 5.991. So now, what can we conclude from this information? So our Kruskal Wallis statistic is less than our critical value. This means we fail to reject the null, and there is not a significant difference to claim that the distributions are not the same. Furthermore, room color does not significantly affect the test scores. So once again, the Kruskal Wallis test is fairly easy, even though the equation looks very complex. Once you figure out what your sum of ranks are going to be and your n's going to be, it's pretty easy going from there to figure out what the test statistic is going to be. As for the critical value, the degrees of freedom are fairly easy to find, and from there, once you have your critical value and your test statistic, it's easy to conclude what you're going to say about the actual problem. In this case, we concluded that the testing room color, in this case, it concluded that the testing room color actually had no significant difference in the actual test scores. Even though the distributions are not normal, it didn't mean that the medians of each distribution were different. So I hope I helped. I hope you enjoyed my video. I apologize for any mistakes I might have made, and I hope you guys have a great summer.